Hello, hi friends. Very nice to connect with you all through this YouTube video channel. So, today we are going to see the functional attributes of carbohydrates in the course Biochemistry of Processing and Preservation. So, myself, Gurumurthy, I am working as Associate Professor, the Department of Food Process Engineering, School of Bioengineering, SRM Institute of Science and Technology, Kattankulattu. So, we all know that carbohydrates from long period we wanted to know today in a different perspective about the carbohydrates with reference to its functional attributes, classification, functional attributes, future prospects and carbohydrate research, challenges, and a conclusion. So, carbohydrate, no, we all know that these carbohydrates are generally defined as hydrates of carbon. They are all biomolecules with a composition of carbon, hydrogen, and oxygen, typically in the ratio of 2 is to 1 with reference to hydrogen and oxygen. So, for example, in the case of glucose, we can see C6H12O6. So, they are the main source of energy. That's what they are called by the name energy yielding biomolecules. Alongside, we can see proteins and fats. Though proteins and fats are yielding energy, but the carbohydrates are the primary sources of energy. For example, you can see starch and other stuffs. So carbohydrates essentially yields energy that is 4 kilocalorie per gram of oxidation of carbohydrates. Some of the carbohydrates are giving structural rigidity, say for instance cellulose and hemicellulose. Now let us see the classification of carbohydrates. So carbohydrates generally classified into simple carbohydrates, that is simple sugars, for example monosaccharides, then disaccharides, then oligosaccharides, and complex polysaccharides or polysaccharides. In the case of monosaccharides, we can see the examples like glucose, fructose, and galactose, and so on. So they also refer to as aldohexoses, ketopentoses, aldopentoses, like that. So it can be named based on the number of carbon atom they possess in their molecule and also based on the functional group they have. Say for instance, aldohexoses. They have aldehyde as a functional group and six carbon atom they are having. And ketopentoses, the keto group as the functional group, and they may have five carbon atom. So like that they can be classified. Next comes disaccharides. So upon hydrolysis, they yield two monomeric units. So they are called monosugars or monomeric units. They are called disaccharides. They bind with glycosidic linkages between monomeric sugars. For instance, cane sugar, that is sucrose, and milk sugar, that is lactose, and also maltose. And now recently, very important class of carbohydrates we come across, that is oligosaccharides. So oligo means in a Greek word few. Saccharides means sugars. So oligosaccharides are almost three to four kind of monomeric units bind with each other by glycosidic linkages. Say for instance raffinose, stachyose, and verbascose. They may also be further classified into fructo-oligosaccharides, galacto-oligosaccharides. They are found to be present in abundant quantity in vegetables, pulses, and other things. Even we can see this presence of galacto-oligosaccharide in human milk. These oligosaccharides having very great industrial applications. We are going to see what all the applications or functional attributes in coming slides. In the case of complex polysaccharides, we can, all very well, starch, which is present in potato, rice, corn, maize, etc., and cellulose, pectin, all those things. They are also further classified into homopolysaccharides and heteropolysaccharides based on the type of monomeric units linked with each other. And the other polysaccharide, glycogen, which is an animal starch, also called as animal starch, which we can come across. Having said that, now let us see the functional attributes of carbohydrates. So some of the carbohydrates, no, they are acting as thickening agents. For instance, starch and hydrocolloids, they are used in industries to increase the viscosity and also increase the viscosity in soups, sauces, and to provide good mouthfeel and also give the good consistency in the case of gravies. And also we can see the application of carbohydrates as a gelling agents or gelating agents, we can say. Say for instance, agar, pectin, and gelatinous starch, they are very much application in jams, jellies, and gummy candies. And some of the other carbohydrates are acting as the emulsifiers. Say, for example, xanthan gum, gum arabic, they are all carbohydrate based gums. They act as a emulsifying agent to mix up the two phases, oil and water phases, and prevents the phase separation in the emulsions and also used in the very much used in the industry for this type of products. And some of the other carbohydrates are acting as a foaming agents. Say, for instance, methyl cellulose, carboxymethyl cellulose, they are having very much application in backed goods, aerated breads, and aerated desserts, whipped toppings, etc. Additionally, these carbohydrates also acting as binding agents. Some of the other starch and gums are acting as binders to hold ingredients together. They are very much useful in food formulations. They are very much important in making gluten-free food products and also snack bar. And some of them are acting as the texturing agents. So they'll give the textures, required texture like crispiness, chewiness, softness. Mainly they have a application in bakery items, noodles, and extruded food products. And importantly, some of the other carbohydrates are acting as the humectants, which means they prevent the drying out of the food product by retaining water, thereby reducing the staleness. And some of the other carbohydrates like starch, maltodextrin, gum arabic, and other things acting as the encapsulating agents. They are very much useful in preparing encapsulation of flavor compounds and other fragile oil-based, essential oil-based compounds. They mainly involved in flavor release system. They are having very good application in pharma industries, nutraceutical and functional food industries. And we can see some of the application in the case of edible film formation. They have antimicrobial properties. Say, for instance, the carbohydrates such as chitosan, xylon, etc. They inhibit the growth of certain microbes. So they have very good application in developing food packaging material with better microbial control. And also they are used as a edible coating material. And importantly, prebiotic properties. Carbohydrates are having prebiotic properties. As we see in the earlier slide, some of the oligosaccharides like fructooligosaccharides, galactoligosaccharides, inulin, etc., they cannot be easily digested by our human system. In turn, they can be easily digested by gut microbiota. So they are called probiotics, such as Bifidobacterium bifidum and lactobacillus based microbes. So they ferment these things and converts into short chain fatty acids, thereby promoting digestive health. They are very much present in garlic, bean, bananas, and whole grains. So now let us see what are the future prospects of carbohydrates. So carbohydrates are increasingly used for gut health, better glycemic control, and weight management. So they are very much essential and come across in the development of functional food products. And nowadays, the usage of alginate, carrageenan are being used as a replacing agents in the case of synthetic thickeners. And some of the modified starch are very much used in making food with improved stability and preparing products of dairy alternatives, bakery and convenience foods. So they are very much used as an ingredient in developing carbohydrate based or plant based hydrocolloids. And also they have very much application in developing eco-friendly plant-based and upcycled carbohydrate-based food production, and also biodegradable edible packaging material development. Now let us see the challenges. So achieving the right balance of carbohydrates for texture, stability, and functionality in different food systems are very much posing the challenges in formulation. And some of the carbohydrates are sensitive. They can alter the gelling capability, thickening, and stability, especially heat, pH, and enzymatic reactions, very much altering the functional properties and affecting the functional benefits. Some of the carbohydrates based ingredients like prebiotics and resistant starch may get degraded over time by thereby reducing their effectiveness. In the case of resistant starch and modified fibers, the availability is very much in demand and less also. So, and also they are very much expensive, which in turn limited the supply. So that is also a challenge, cost and availability. Next comes growing demand for low carb food products, keto food products, and sugar free diets, which are challenges to develop the traditional usage of carbohydrate based food products. And regulatory compliance, meeting the global food safety standards for developing carbohydrate alternatives, fibers, and sugar substitutes while maintaining clean label formulations. To conclude, carbohydrates contribute to texture, stability, moisture retention, thickening agents, and emulsification agents in food products. They have wide application in bakery industries, dairy and beverage industries, and functional food product development industries, and for enhanced quality and nutrition. So, in the case of future direction, carbohydrates have innovative applications to develop sustainable carbohydrate-based products, low GI formulations, and clean label products, etc. So, for further information, please refer these references, and we will touch up with you with more detail on modified starch and how to synthesize chemically these modified starch and what are the application in food industry in detail in coming sessions. Thank you for patient listening. Wish you all the best.